In the last two presentations, we have understood bitwise operators in details. We have understood 4 different operators: AND, OR, NOT, and XOR. Now, from this presentation onwards, we will understand bitwise shift operators. And in this presentation, we will understand bitwise right shift operator, which is one of the bitwise shift operators. So let's get started with this presentation. The first topic of this presentation is Introduction to Bitwise Shift Operators, and the second topic is Bitwise Right Shift Operator, which is denoted by these two greater than symbols. Let's start with the first topic, that is Introduction to Bitwise Shift Operators. So what is a bitwise shift operator? Bitwise shift operator shifts the bits of a binary number towards the left or right. So first of all, we need to understand that bitwise shift operators are bitwise operators. Therefore, these operators can only be performed on bits or binary digits. And bitwise shift operators shift the bits of a binary number either left or right. There are a total of 2 bitwise shift operators in Python. The first operator is bitwise right shift operator, which is denoted by 2 greater than symbols, as this symbol is also indicating that this operator will shift the bits towards right. And the second operator is bitwise left shift operator, which is denoted by these 2 less than symbols, which indicates that this shift operator will shift the bits towards left. In this presentation, our focus will be on bitwise right shift operator. We will understand bitwise right shift operator in details. So let's move on to the next topic, which is bitwise right shift operator. So what is a bitwise right shift operator? Bitwise right shift operator shifts the bits of a binary number towards the right. As the name itself suggests, it is a right shift operator. So it shifts the bits of a binary number towards the right. As a consequence, it divides the number by 2 to the power n, where n represents the magnitude of shift. We will understand now these 2 points with the help of an example. Let's consider this simple example where a is equal to 12. This number is in decimal. We first need to convert this in binary because we want to perform bitwise right shift operation on this number. It is important to convert this number to its equivalent binary form. A in binary is 01100. We have already learned how to convert decimal numbers to their equivalent binary forms. One thing to note here is that this bit represents the sign bit. As this bit is 0, therefore the number is positive. Now let's perform the bitwise right shift operation on this binary number. For this, let's write A right shift 1. Here 1 represents the magnitude of shift and A is the operand, and this right shift operator is saying that shift all the bits of A 1 step towards right. So here we need to shift all these bits 1 step towards right. So the result will be 00110. And note that the sign bit will remain same, that is, we must put 0 here because the original number has the sign bit 0. So one thing is clear, that when we shift the bits towards right of a positive number, the number will remain positive and hence the sign bit must be 0. This binary number is equivalent to number 6. Now as we have learned how to shift the bits of a binary number towards the right, let's understand the second point where I have mentioned that it divides the number by 2 to the power n. N represents the magnitude of shift, and in our example the magnitude of shift is 1. So here we need to replace n by 1. We will get 2 to the power 1, which is equal to 2. This means that we need to divide the original number by 2. The original number is 12. We need to divide this number by 2. We will get 6 as the result. And this is what we are getting here. Now let's see one more example to concrete this concept. Let's perform A right shift 2. This time the magnitude of shift is 2 and this bitwise operator is saying that shift all the bits of A 2 steps towards right. This means we need to shift all these bits twice. We have already performed the bitwise right shift one time. We just need to shift these bits one step towards right. So we will get this binary number as the result. We will get 0, 0, 0, 1, 1. All the bits are shifted one step right. And remember that the sign bit will remain 0. This binary number is equivalent to value 3. Now as the magnitude of shift is 2, we need to replace n by 2. We will get 2 to the power 2 which is equal to 4. This means that we need to divide the original number by 4. So let's divide this number 12 by 4. 12 by 4 is equal to 3 and that is what we are getting as the result here. I hope the concept is completely clear how bitwise right shift operator works. Now let's open our command prompt and activate the Python interactive shell. Let's type this command A equal to 12, then hit enter. Let's type A right shift 1. After hitting enter, we will get 6 as the result. Now let's type A right shift 2 and hit enter. We will get 3 as the result. So we have verified this also that the right shift operation is working correctly. Now let's see one more example where we will consider the negative number and we will try to shift the bits of that negative number towards the right. Let's see how to do this. Let's take one simple example. This time we will take minus 12 and we need to represent this number in its equivalent binary form. So the main question is how to represent minus 12 in binary. We have already learned this while discussing the bitwise NOT operator. For this, first we need to represent 12 in binary. We have already seen this that 12 in binary is 0, 1, 1, 0, 0. Now, the step number 1 is we need to take the ones complement of this number. Now let's take the ones complement of this number. We just need to flip all these bits. Zeros becomes ones and ones becomes zeros. So the result is 1, 0, 0, 1, 1. Now the step number 2 is to add 1 to this ones complement result. So now we will add 1 to this result. To this number 1, 0, 0, 1, 1, we now need to add 1. By adding these two ones, we will get 0 as the sum and 1 as the carry. Again here we will get 0 as the sum and 1 as the carry. Here we will get 1, 0 and then 1. So the result is 1, 0, 1, 0, 0. This is the binary representation of minus 12. Now as we know the binary equivalent of minus 12, we are now ready to shift the bits of this number. So it is clear that A in binary is 1, 0, 1, 0, 0. Let's now shift these bits towards right. A right shift 1. So we now need to shift these bits towards right only once. We will get this as the result. 1, 1, 0, 1, 0. Note that here the sign bit is 1. Therefore, the sign bit will remain same. We will not put 0 here. We will put 1. The number will remain negative. It will not suddenly become positive. This binary number is equal to this value minus 6. Why is that the case? The positional weight of the sign bit is minus 2 to the power 4, which is minus 16. The positional weight of this bit is 2 to the power 3, which is 8. And the positional weight of this bit is 2 to the power 1, which is 2. 8 plus 2 is 10 and minus 16 plus 10 is minus 6. So this is the reason why we are getting minus 6 as the result. Now let's verify this result by putting 1 here, as the magnitude of shift is 1. So 2 to the power 1 is 2 and now we need to divide the original number by 2. We will get minus 6. I hope this is clear. Now let's perform this operation, A right shift 2. This time we need to shift all these bits towards right twice. We can shift these bits also once. So we will get this as the result 11101. All the bits are shifted right, and note that here also the sign bit is 1. This binary number is equal to -3 in decimal. And you can verify this also by putting n as 2, 2 to the power 2, which is equal to 4. Divide -12 by 4, we will get -3. And this is what we are getting here. Now let's open our command prompt and verify the results. Let's type A equal to -12 and let's hit enter. Now let's type A right shift 1. After hitting enter, we will get -6. Let's now type A right shift 2 and hit enter, we will get -3. So we are done with this topic as well. This means we are done with this lecture. Okay friends, this is it for now. Thank you for watching this presentation. I will see you in the next one.